Then we come to what is a fluid. How do we define a fluid? Now, for that, we need to recall from physics that normally the substance is categorized into three primary phases: solids, liquids, and gases, as we normally know. Now, a substance in the liquid or gas phase is referred to as a fluid. Now, we say that the liquid or a fluid or a gas is a liquid or a fluid, but how do we define it? What is its essential property? The property is that when we apply an external force into this, then any fluid changes its shape without any resistance, whereas a solid will resist. So that's the difference, and that is how we recognize them. Distinction between a solid and a fluid is made on the basis of the substance's ability to resist as an applied shear or tangential stress. So again, the same thing that I have just mentioned. If we apply a force in a lateral direction, if there is a solid, it will resist it and will not easily move under the force that has been applied. But whereas if we apply the same thing on a fluid, which means liquid or gas, it readily changes its shape. For example, to understand it easily, take any liquid, put it in any type of utensil or container, you will see that it will convert itself into the same shape. A solid will not do that. In fact, if you apply too much, it's going to break. But for a small portion, for a short time, that may not do so. A solid can resist an applied shear stress by deforming, whereas a fluid deforms continuously. So, as I explained, that if you apply an external force on a solid, it does deform. Consider any solid. There is a Hooke's law, for example, in which if we apply a force on a wire, then it can be it can change its length or increase its length by a small distance, and we call it as a strain, and that strain is considered to be as proportional to the applied force. But that is in case of solid, and if we apply too much force, that can tend to even break it. But when it comes to liquids or gases, then they deform continuously without providing any resistance, and it's not going to deform into another type of fluid. The influence of shear stress, we will come to different equations, formulas for these terms that I am using: shear stress or tangential stress, and so on. These are all forces that we are applying. Shear stress, if we apply even in a small quantity to a liquid, it will change its shape. But if we apply it on solid, a small stress will not make any difference. But anyway, it's well known in physics, and most of you would know it already, that in solids stress is proportional to strain, but in fluids stress is proportional to stress strain. See the difference. In solids, the stress is proportional to strain, whereas in fluids it is proportional to strain rate. So this is a important difference that differentiate the two types of mass. Stress is defined as force per unit area. Now, stress is a term that we do every day. We use it, and it can be, in scientific terms, we use it as a force, and of course, it's a different components that I will be elaborating on. But even you will see that even in our daily life, we say, "Oh, I am facing too much stress these days," or the other person is feeling too much stress. So this terminology is being used. But when it comes to scientific force, then it is the external force, and the force in the usual sense of the meaning, when it is applied per unit area, then it is determined by dividing the force into area upon which it acts. If the force is being applied in a perpendicular direction, we say that this is pressure. If it is applied in a tangential direction, for example, I have said it in other words, the normal component of the force acting on surface per unit area is called normal stress. The normal component, that is the component that is perpendicular to the surface upon which the stress is being applied, the force is being applied, is called stress, or the normal stress. But if we apply it in a tangential direction, which means tangential to the surface on which the force is being applied, then the component of force acting on that surface per unit area is called shear. So in tangential direction, the force is called shear, but in the normal direction, it is called normal stress. And many times, that is the term we know as pressure. Pressure is force per unit area. In a fluid at rest, the normal stress is called pressure. I have already said the normal component that is applied on the surface is called pressure. Normally, that's the word that we use, or the terminology. And a fluid at rest is at a state of zero shear stress. So if there is no movement in a fluid, then there is no shear stress that is being applied on that. So these are general definition of fluid, in which we mentioned that it deforms when the external force is applied, and that differentiates it from the solid bodies. And then when we apply the force, then we have utilized two terms, the shear stress, the tangential stress. Shear stress is called shear, while the normal stress, normally we call it as pressure. We elaborate them further when we come to the equations of motion.